Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to yet another edition of our online class coming to you from Islamic College Osogbo. This is Ss3 chemistry class. In the last few weeks we have been looking at solution to the questions that came out in your mock examinations, and today inshallah we are going to continue on that. The area we are looking at currently is the practical examination questions. We have looked at question 1, which is for the medical analysis during the last lesson. Today we are going to look at question 2 and 3. Question 2 is of qualitative analysis or SWOT analysis, and question 3 is a general laboratory practice. Now question 2, the question states that you C is a solution of an inorganic salt to about 2 cubic centimeters of C, add sodium hydroxide solution in drops till excess. This is what you are already familiar with. To solve this type of question, what you need to do is to draw a table showing tests, observation, and inference. Your test is what you are going to carry out. Your observation is what you observe after carrying out the test. Then the inference is what you can bring out from the result of your test. And the table that you are expected to draw is like this. Now, so you have solution C added to, and you have a sodium hydroxide solution. You have to add the examiner asks you to add sodium hydroxide solution in drops till excess. This is how you are going to set up your test. Solution C, or simply C. Since C is given to you in solution form, so it is not going to be solution of C or C aqueous. Solution C or C simply plus sodium hydroxide aqueous. This AQ is very important because it is the one that is telling us that we are using solution of sodium hydroxide and not sodium hydroxide pellet. Now, if anything is wrong with this test, anything is wrong with the way you record your test, then whatever you write under observation would not get any mark. And if you don't get any mark for observation, you will not get mark for inference. Please take note of that. As simple as the word, these letters AQ, showing that solution you are using sodium hydroxide solution, as simple as the letters are, without those letters, no mark will be obtained here. No mark will be obtained here, because it means what you are. If you don't write AQ, for example, now it means what you are saying is that instead of adding sodium hydroxide solution, what you have just done is that you have added sodium hydroxide pellet. And if you add sodium hydroxide pellet instead of sodium hydroxide solution, you will not get the required result. And if you don't get the required result, how will your observation be correct? So even if you write the correct observation, what the examiner will assume is that you have just copied somebody, and then you will not get any mark. If the observation is wrong, your inference cannot be right. Please take note of that and ensure that this is one of the reasons many students lose mark in this particular type of question. Now, during the test, after adding sodium hydroxide solution in drops, with blue precipitate was observed. This is how to write it: blue precipitate formed, and that hints us that the solution might contain copper 2 ion. And when the sodium hydroxide solution was added in excess, the blue precipitate remains insoluble, and this is also typical of the type of reaction that copper 2 ion undergoes. Now next is the question 1A2. To another 2 cubic centimeter portion of C, add few drops of dilute trisulfite 5 acid followed by drops of silver trisulfite 5. Now, what is related here is the tabulation of your result as usual. Now the table, you have test, observation, and inference as usual. So solution C plus trisulfite 5 acid aqueous, AQ, very important as well. Then plus silver trisulfite 5 AQ again. Now you obtain white precipitate, and the precipitate you have obtain white precipitate. Nobody has asked you to add silver trisulfite 5 solution in drops till excess. It's only in drops, so you have to add in drop. Some of you will be writing in drops in excess again, when the examiner has not asked you to add it in excess. So you just you just write it there, as we have written it here. It's only when they ask you to drop it in drops till excess that you are going to see in drops in excess under your test. So please take note of that. So white precipitate was observed, indicating that the solution might contain chloride ion. Now note that this question can also come in another way. The question can also be can I direct you to add sodium hydroxide, silver trans-identified solution before the excess dilute triosolated 5 acid. So when the question comes like that, the results would be different, because when you add silver trans-identified solution, you get white precipitate. When you add triosolated 5 acid, the white precipitate remains, and that will tell us that it is chloride ion. Please take note of that. So it can come, the silver trans-identified 5 solution can come before the trans-identified 5 acid. So whichever one comes first, white precipitate will be observed. Now, question 2b. This is solution of an organic compound to about 2 cubic centimeter portion of the add few drops of Fehlin solution followed by heating. So now you have an organic salt, you have to carry out a test on it. The same procedure, tabulate and record your observation and inference. Now you are asked to add Fehlin solution, then heat. That means D plus Fehlin solutions plus heat. That's your test. Then orange red precipitate was observed. That's what we did. That's what we observed that day. And then the inference in that case, when you add Fehlin solutions to a sample and you get orange red precipitate after heating, the inference is reduced sugar or simply glucose present. Now the next question is question 3, and you know that question 3 always deals with laboratory experience or laboratory procedure or laboratory activities or all the experience that you are expected to have had during your process of learning. And in this case, the first question, which is question 3a, under here, is asking you to state the color of certain substances. Manganese 4 oxide, it is black in color. Acidified potassium tetrahydrocarbonate 6 solution. Acidified potassium tetrahydrocarbonate manganese 7 solution is purple in color. Acidified potassium heptadichromate 6 is orange in color. Ion 2 chloride is green in color, just like any other ion 2 compounds. All ion 2 compounds are green. All ion 3 compounds are brown or reddish brown or yellowish brown. But it should, at least they are brown. But ion 2 compounds are always green in solution. So please take note of that. So the next question is question 3b. You are asked to classify certain normal salts based on the pH of the ICOS solution using the table that follows. You have K2CO3, Na2SO3, MgCl2, Fe, Cl3, CH3COO, Na, and the CaSO4. Now, all these salts, when they dissolve water, what will be their pH? Will the pH be equal to 7, less than 7, or equal to 7, or greater than 7? Now, how do you know that? You have to consider the acid radical and the basic radical in the compound. If the acid radical is strong and why the basic radical is weak, then it means the solution will be acidic. If the acid radical is weak, why the basic radical is strong, it means the solution will be acidic. It means the solution will be alkaline. If the acid radical is strong, while the basic radical is weak, it means the solution will be acidic. Why, if the acid radical is weak, while the basic radical is strong, it means the solution will be basic or alkaline. And you have to also remember that strong basic radical are potassium and sodium, while strong acid radicals are tetrasulfate 6 ion, chloride ion, and trans-identified 5 ion. So at least these are the common strong radicals. Now whenever you see potassium or sodium ion in the salts, just look at the acid radical.
So if it contains trans-95 NaNO3 or chloride Cl or tetrasulfate SO4, it means the solution will be neutral. But if you look at the acid radical and does not contain any of these three, it means the solution will be basic. Once it contains sodium or potassium ion as the basic radical. So let's look at this. We have K2CO3 here. This is strong basic radical, but this weak acidic radical. So it means it's going to be basic, and that means the pH will be greater than 7. Na2SO3, strong basic radical, weak acidic radical as well. So it means it is basic, that pH is greater than 7 as well. NgCl2, weak basic radical, strong acidic radical. It means it's going to be acidic, pH less than 7. FeSCl3, weak basic radical, strong acidic radical. It means it's going to be acidic. CH3COONA, weak acidic radical, because this is ethanoate from ethanoic acid. Strong basic radical, it means it's going to be basic. That is pH greater than 7. CaSO4, weak basic radical, strong acidic radical, it means it's going to be pH less than 7. That is acidic. Unfortunately, among all these sea salts, there's no one that the solution will be neutral. So, and that is what we have in the expected answer in the table that follows. Now, next is question 3C1, where you are asked to sketch a diagram to show how you would separate a mixture of water and kerosene. When you have this type of question, when you have two liquids mixed together, you have to look at miscibility of the liquid. When, from your experience, will water mix with kerosene? Definitely no. Water will not mix with kerosene. It means the two liquids are immiscible liquids. And when you are separating a miscible liquid, you need separating funnel, which is shown in the diagram that follows. So separating funnel is like this, and this mixture is poured inside it. The denser one, which is water in this case, will be at the bottom, while the lighter one will be at the top. So when the tap is open, the denser one comes out first. Once the layer, at least the layer is formed between them, once we discover that the layer is all the liquid at the lower layer has been collected, and inside our collecting vessel, we close the tap and then leaving the lighter liquid. So this is how the mixture is separated. But if it is miscible liquid, then we use fractional distillation or distillation, so to separate them. Now, the next question is name the main apparatus used in that experiment, and that's the name of the apparatus there is simply separating funnel. I pray Allah grant you understanding of the lesson and understanding of all your learnings. Inshallah, as from next class we'll be looking at some other areas of the syllabus. I pray Allah grant you success in all your endeavors. Make sure you check your portal and do the assignment.